Hey guys, let's talk some quadratic applications. So what that means is applications are problems that deal with quadratics, parabolas, etc., but they're essentially word problems, so ways that quadratics work in the world around us. So in our example, we have Alan jumped off a cliff into a river. His height as a function of time could be modeled by the function h of t equals negative 16t squared plus 16t plus 480, where t is the time in seconds and h is the height in feet. What was Alan's maximum height? Now, I don't know about you, but it's hard to visualize what in the world is going on with an equation like this. But what we do know is Alan jumped off a cliff into a river. So what I'm going to do is I like to draw pictures to kind of have a good idea of what's going on. So let's say that is a cliff and down here is our river. So Alan was on the top of this cliff and, just like anyone else, when you jump, you're going to go up and then you're going to come down and fall into the river. So that's kind of the path that Alan is traveling. And if you look at it, even though this is a picture, if you look at it, if I kind of get the symmetry here, you're going to see that there is a quadratic here. There's a quadratic. So what they want to know about is what was Alan's maximum height. So looking at this picture, it's a lot easier to point at and pick out where does this maximum height happen. Well, when you jump, you're going to go up a little bit, and then you have gravity takes over, brings you back down to the water. So this point right here, this should be the max height. So we want to know all about this point. So this is where the idea of Alan jumping into a river in mathematics, specifically quadratics, collides. So this point right here, the maximum height, if you look at it, is also known as the vertex. So really, they're asking about what in the world is happening at the vertex. So let's try and figure out what this vertex is. So when I go and look at my equation, I have h of t equals negative 16t squared plus 16t plus 480. Now we've talked about whenever you see h and t and stuff like that, it's really like y equals, and you have negative 16. Well, in this case, I thought we were going, I'll back it up there really quick. We're dealing with h equals, because we are dealing with h there, h equals negative 16t squared plus 16t plus 480. So we've looked at a lot of different quadratics and a lot of different forms. This is very similar to y equals ax squared plus bx plus c. But instead of x and y, we're dealing with t's and h's. So in standard form, we got to find the vertex. So we got to think back on what are ways that we can find the vertex in standard form. Well, how we discovered that is we're going to use that h or x equals negative b over 2a. This will help you start getting the x value of the vertex. So let's start by doing that. Looking at my equation, a would be negative 16, b would be 16, and c would be 480. So if I know a is negative 16, b is 16, and c is 480, let's use that information in this equation. So this gives us the x value of the vertex. So start with a negative 16. So I have the negative, b is 16, divided by 2 times a, which is 2 times negative 16. So simplifying this, we get a negative 16 divided by 2 times negative 16 being negative 32. Negative 16 divided by negative 32 is 0.5 or 1/2. So when I'm trying to figure out my vertex, I know the first part of that is 0.5. But let's get complete and full information here. I want to know the complete vertex of this quadratic application. So if I have one piece, I could figure out the other. So this piece right here is 0.5, which is in the x position, which in our specific problem would be t. So I know t is 0.5. So let's just plug in 0.5 into this equation and see if we could figure out h. So plugging in, we would have h equals negative 16 parentheses 0.5 squared plus 16 times 0.5 plus 480. After that, we're just off to using our calculator to figure out what's going on. So, pulling up my calculator, I'm just going to type in everything you see here, parentheses and all. So I'm going to have negative 16, parentheses 0.5, parentheses squared, plus 16, parentheses 0.5, parentheses, plus 480. That gives us an output of 484. So what I just found out was the other part of my vertex is 484. So it looked like T was in the X spot and H is in the Y spot. So I know T is 0.5, H is 484. So let's go back to the question here. It says, what was Alan's maximum height? So we wouldn't report this entire vertex. Yes, we are interested in the vertex because that's where the maximum is. We just care about the height only. So looking at the coordinates of my vertex, 0.5 is time, so it looks like 0.5 seconds. And my height is 484, which is feet. So the answer to this problem is just 484 feet is the maximum height. And that is a quadratic application. Now I will tell you with these problems, it can change from scenario to scenario. Sometimes it could be maximums, and sometimes it can be minimums. It could be either or, you just look out for it, but no matter what, you're usually dealing with a vertex. So again, that was quadratic applications.